Scheduling of work and monitoring of work. That is what we will be talking in today's presentation. This particular topic will be a little bit on the heavier side. People who have an engineering understanding would be able to understand and decipher the presentation very easily. But I am trying to put absolutely this particular presentation in the most feasible, lucid language that is possible so that everybody can understand, keeping the base concepts of the audience in mind. I am just going through this presentation. I hope all of you will appreciate the same. So let us understand with the definition of scheduling. It is routing the operations that needs to be performed, their sequences, the work centers, and the time standard. So it's basically small milestone that we need to go around it, which each milestone there has to be set objectives that has to be completed. Remember, all milestones are basically subset of objectives that actually belongs to the overall objective that comes around it. A bottleneck, on the other hand, is a resource whose capacity is less than the demand that has been placed upon it. So I can produce only 10 chairs in a shift, but I have been asked to produce 100 chairs in a shift. Probably there is something which will go wrong. Even I at the best scenario that I can do is having 20 chairs in a shift, but then the productivity might be improved, but the quality of the product might be come out to be inferior. Now, this is what is the bottleneck where things get jammed around it. The things get jammed because of certain valid reasons. So basically, a resource whose capacity is less, as I've given you an example, and where the demand has been placed on a higher end. The other thing is all about due date, when the job is supposed to be finished. The milestone, did I say around it? Yes. Slack is a time that the job can be delayed and still be finished within a particular span of time. And queuing is a waiting line that comes around it. It is you wait for your chances, you wait for your productions to happen. There are certain lead time that needs to be taken care of. Remember, I have already initiated the topic of scheduling and this through a production process altogether for you to understand what is scheduling is there in an organization. So let us understand the high value operation. High value, also known as flow operation, like automobile, bread, gasoline, can be repetitive or continuous. And mostly in a mass production industry, everything is repetitive altogether. We are encountering with high volume standards items, discrete and continuous, smaller profit margin, designed for higher efficiency and high utilization. High volume flows operation with fixed routings and routings. How do you go around it? The bottlenecks are easily identified and everybody knows about it. It's very commonly used in line balancing to design the process around the required task. Is it what we are looking for? It the characteristics of high volume operation. Now, once we have talked about the high volume operation, which is basically mass production of goods, now let us compare it with a low volume operation. Low volume operation are done in a small job shop operation and designed for flexibility. It can be customized to the requirement. So what does it do? It is used more for a general purpose equipment. Definitely, yes. Customized products with a higher margin. Obviously, since it's been customizing the product, you are keeping the margin very good enough. Remember, the mass production will always employ the economies of scale, which might not be the case in a low volume operation. Each product or services may have its own routing or routing scheduling is much more difficult out here because you need to prioritize as on one basis. Bottlenecks move around depending upon the products we produced at any given point of time. So bottlenecks you will not be able to identify, and bottlenecks are created by a lot of factors that can be entailed into it in a low volume operation. In high volume operation, bottlenecks are clearly identified and everybody understand what is going right or what is malfunctioning as a result. So that's the beauty of difference between a low volume operation and a high volume operation. Gantt charts and a low volume tool is developed way back in 1900s by Henry Gantt and still applicable. I still find it very basic and fundamental to the various software that has been coming up for your scheduling technique, project management techniques. Come what may, we might be talking about Primavera, we might be talking about so many software that has been there, that's been flooded in the market. Now, load charts illustrate the workload relative to the capacity of the resources. Let's say it's a job that needs to be done, and it been the number of mechanics that you have been plotted it, Bob, Sam, Alex, JJ, or John, if you want to go it. The time frame for every 1 hour, 8 to 9, 9 to 10, 10 to 11. Now they are doing which, who is going for which jobs. As in, remember, 12 to 1 is roughly the lunch time that has been given to them. It's akin to your timetable for a school, for a college, as in what the things would be, this being the subject that has been taken. But essentially, yes, once you're finished, all the jobs, your work gets completed, and all the mechanics are doing their jobs. They have been scheduled as to what to be done, when to be done, and who is responsible for which jobs around it. But what about the progress chart? Now, in a progress chart, it shows a number of tasks. Now, this is what we are talking about it, wherein we are scheduling the actual performances. Now, we are not manning for a person to a job or a task. We are showing what all activities that needs to be completed. Let's say design specification in the early part of the year. Then probably sources of the material. Once design has finished, you start, you initiate. But along with sourcing the material, you can design the process simultaneously. They start, and once the sourcing of the materials finishes, it continues for the designing process. And remember, there is an interruptions or interpretations as far as the pilot runs are concerned, and so on and so forth. And this is what we are looking into it, wherein we, by the end of June and July, we are not only manufacturing and we completing the progress. So yes, the planned activity process and the actual activity which might be taking place as on when on places. So this is planned out here, but it is actually taken in the month of May. Probably there is a slack that comes around it. It has been planned out here and been done as on when on basis, has been going around the feedback and the transition to manufacturing. So this is Gantt chart in reality, what happens actually. So scheduling of the workload, if you look into it, which has been planned and which has not been planned, we are talking about infinite loading and finite loading. You know, infinite loading, there might be overutilization, equal utilization at 2 quarters. There might be overutilization and there is an underutilization. Similarly, over for one, the under for one. You're making a balance for other thing. It ignores the capacity constraint and helps identify bottlenecks in a proposed scheduling to enable proactive management. Now, I am trying to make you aware of scheduling process without the nitty-gritties of engineering. This could have been very well done with a live example with a lot of mathematics and what involved into it and how do we go around it. But for better understanding, I am using a graphic user interface for you to comprehend what exactly is meant by scheduling work and workloading. We have spoken about infinite loading, right? As in when on basis, we keep on fire, do it, and it becomes, it basically helps us in identify the bottlenecks and when the schedule management process. And bottlenecks is where we can keep it underutilized and overutilize somebody. But what happens when there is a finite loading? Absolutely everything has been mashed around it, allows only that much of work as has been assigned can be done within the available capacity, but doesn't prepare for inevitable slippages. Now slippages is something, if you look into it, here is an inevitable switches. What goes wrong? Probably there's a manpower shortage, maybe, I'm just guessing. Probably the equipment malfunction. So these are the slippages that comes up. But remember, the slippages are once in a blue moon. The rest of the time it goes as per plan. So something to be understood as scheduling work or workloading in terms of infinite loading and finite loading. Believe me, I'm trying to give you a perspective, right? So other scheduling techniques is what we are doing about is forward scheduling and backward scheduling. Starts the process from the job. So I can do as of today, what do we do? How do we start? Probably, and probably give the milestone altogether, or the other way around, the backward scheduling. I know what my objective is all about it, right? This is my due date. I need to finish this particular thing. I need to be here in this particular time. So can we backward finding it backward? So what time will be going to the final state, the third state, the second state, the first state, and the materials order. Now if you find it, there's a plentiful of gap which is equivalent. So what does it helps me is, even if I start out here, I have a lot of laxity that comes around it, and probably I can finish it. I can duly finish it before time, or I can finish it on time. There's nothing that I am not still at the culprit. Or the other way around is in a backward calculation, I have a slack out here. I have the luxury to start late. and still finish on time. So backward scheduling is begin scheduling the job last activity, so the job is finished on the scheduled dates. So this is what a pictographical interface for your understanding altogether. So monitoring workflow, let's say input output control, is a capacity to control techniques altogether. You know, your monitor of work is all about it. Monitors how it is to be done, what is the planned available capacity, and how do you process it as on when on basis. So you have your planned things, right? Planned input, actual input, deviation, the period 4, 5, 6 period. Your planned input was 800, your actual input was 750. So you are lacking on 50, minus 50 are going around it. Output in hours similarly can be calculated as or when on basis. And basically what I'm trying to do is finding a lag time. What are my deviation that comes around it? What are my backlog in terms of hours? How will I be able to finish the project within the due specific time, due specific cost, and so on and so forth. Quality being not been compromised at the end of the day. So input output control technique for your understanding. Remember, this is what we have been trying to give you an understanding. So how to sequence job? First thing first is to prioritize job. Which of the several jobs should be scheduled first? Prioritizing is important. Techniques are available to do short-term plannings and job-based jobs, job-based capacities and priorities thereby. Now let us understand. I have already stated earlier. It is all about prioritizing. Prioritizing rules, decision rules to allow relative priority of jobs at a work center. Local priority rules determine priority based only a job at the workstation. Global priority rules also considers the remaining workstation a job must pass through eventually. And that is what we are going to say about the priority rules thereby. This is how to sequence job. Now let us understand what the commonly used priority rules. First come first serve is FCFS, or last come first serve, or LCFS. Now that is how you want to go around it. Is this the priority that goes around it? Probably everybody would believe that first come first serve is the best methods to entangle. Probably. Then there is something called earliest due date. Is the earliest date that we need to finish it up. Now, earliest due dates are being prioritized when there is an incentive given to you. If you do it within this number of days, you get a 10% incentive overall to the budget. If you do on a later date, probably that incentive has been withdrawn altogether. So that becomes an earliest due date. Shortlisting processing time, at the shortest processing time is completing the critical activities time and again, and the longest processing time where you take the luxury and probably never ever compromise on the quality. But once you have said about the longest processing time, ensure that you are strictly following it and ensuring the completion of the project within the date. Then last thing would be your critical ratios. Now this is the time until due date and divided by processing time. So what is my time? I can make only 10 chairs in a shift, and there is an order for 100 chairs. So will I take 10 days to do it? Probably. For every day I'll do only one shift. 10 days means approximately 2 weeks, considering the fact there are 5 work days for a week, right? So should I say 2 weeks time, or should I take an extra 1 day or extra 2 day to just to be on the safer side? So that is what the critical ratios are all about. It slack for the remaining amount of the operation, which is slack is the extra date that I count to go around it, or the number of remaining operations that needs to be finished out. These are the most commonly used priority rules ever to be encountered, to be understood thereby. Now, how to use them? Decide which priority rules to use based on the demand of the project. That is what you go around it. List all job waitings if there are any. If there you are already in the middle of certain things, how do you finish them, wind it off before commencing with the other jobs? Using priority rule, determine which job has the highest priority, then probably the second, then probably the third, and so on and so forth. So measuring performances, yes, this is of utmost importance. Until and unless you are able to measure performance, nothing matters. So job flow time is what we looking into it. time a job that's completed minus the time a job was first available to processing is the average flow time that needs to be done. We are going to talk about the average number of jobs in a system. It's measure of the work in progress. It's the work in this system. So the average number of measure responsiveness and work in progress, WIP inventory that is going around it. Remember, every of the job is of vital importance. You cannot remain keep a task incompleted, keep a work incompleted thereby. Make shift how to go around it as when on process that needs to be taken forward. How do you go approximately? The job lateness is where the job is completed ahead of or on behind the schedule if it is going wrong altogether. Job tardiness is how long after the due date a job is completed. Measure the due date performances thereby. So this is what we are looking as far as job is concerned. Remember, job flow time, average number of job in the system, the make span, the job lateness, the job tardiness is of vital importance. Let me give you two work centers rules altogether. That is what is the Johnson's rule states. The Johnson rule states a technique for making a makeshift project is unidirectional project. Step one, list the jobs and process time every time. Like in a Gantt chart, we go around it. Step number two, find the shortest activity process time along with the jobs yet not yet scheduled. Shortest possible activities. If the shortest processing time is for the first activity schedule, then the job is the earliest available in the job sequences. That is what we will always consider. Look for the shortest possible down the time for the first activity, because only when the shortest possible time is done for the first activity is completed, then the second activity can be scheduled and schedule the job until the last available position in the job sequence. When you schedule job, eliminate it further into further consideration and repeat step number two and put all the activities in a job as on when. So it is the watertight way of completing the jobs. As I said, if I can make 10 chairs in a shift, so the shortest possible time would be 10 days for 100 chairs to be done, right? That the only after finishing the 10th chair can I move on to the 11th chair or the next shift. And I have to ensure that every shift I am completing at least 10 chairs, right? So that is how we are going to go ahead with it. So repeat this thing and you will see the jobs have been sequenced every now and then. Now there is a process called bottlenecking, which is an irritant factor in probably the scheduling thing. Now Ellie Goldratt introduced something called OPT. In fact, this is something which is absolutely a must for every production and operation person to know about it. Optimized production technology. What is they all about it? Come, let me tell it to you. Optimized production technologies focuses just only on the bottlenecks for scheduling, capacity, and planning. Because bottlenecks, once it has been clear of all the pending job, the rest of the jobs will be taken care by itself altogether. So by definition, it is a throughput, the quantity of finished good that can be sold. It's the number of people, the number of output that actually can be accessed through after a period of time. Transfer batch, quantities of item moved in the same time for the one resources to the next, as the case might be. The process batch is quantity produced at the resources before switching to another product. That is what is of utmost importance to the rest of the people that has been carried forward to it. So optimized production techniques would improve the balance that processes for the flow, absolutely the flow. Non-bottleneck usage is driven by some other constraint in the system. It might be resources, it might be equipment, it might be manpower. You name it, we have it. Usage and activation of resources are definitely not the same. It is two different things. What needs to be activated and what needs to be used. An hour lost at a bottleneck is lost forever, but an hour lost on a non-bottleneck is a mirage that comes around it. Let us understand what bottlenecks are all about. It is the throughput and the inventory in the system. If there are bottlenecks, if there are a lot of job been assigned and they are yet to be finished completely, the pending job, the rest of the jobs are pending the completion of the bottleneck jobs altogether. So it determines the throughput and the inventory in the system. The transfer of the batch does not need to be equal to the process batch altogether, and that is what we always claim out here. The process batch should be variable, Consider all constraints simultaneously. Lead times are the result of your schedule and are definitely not to be predetermined. That is what the optimized production technique is all about. It. Let me explore the theory of constraint. Now, theory of constraint or TOC is an extension of optimized production production technique is all about it. A system where the output is determined by the constraint. Now, the constraint can be money flow, constraint can be resource flow, constraint can be manpower flow, constraint can be electricity flow, constraint can be facility oriented, constraint can be political, constraint can be economical, constraint can be ecological. There are so many theories. There are so many constraints. So we need to identify these things, identify the bottlenecks. Remember, theory of constraints is just an added extension to the optimized production techniques is all about it. Now let us go and fully utilize the bottlenecks. Can we append, or should I say, can we diversify? Can we enhance the bottleneck, thereby subordinate all other decisions to step number two? Schedule non-bottlenecks to support the maximum use of bottleneck activity. Elevate the bottlenecks. Do not let inertia set in. This is of vital importance. So scheduling of service organizations is demand management, appointment and reservation, posted schedules, delayed services or backlog as on when on basis, the queues that comes around it, the appointment, the reservation, the posted schedule. Then comes the scheduling of employees, staff for peak demand if cost isn't prohibitive, floating employees or employees on call, temporary, seasonal or part-time employees that we are setting out to be. That is what we are looking out here every now and then. This is the scheduling of the service organization. Now we are looking only at the service sector. First to manage demand and then to schedule employees. Demand on weekdays or weekends. Demands to look after at the appointment, and probably then do the posting of schedules of the employees for the peak hours and non-peak hours, temporary, seasonal, part-time employee. So scheduling with operation management, how does it fit all together? Let us understand scheduling is a final planning that occurs before the actual execution. So this is which is very important as far as this thing is concerned, as far as production is concerned and scheduling is concerned. At the end of the day, remember, this is critical because the master scheduler evaluates the production planner every now and then. Schedules are essential on the shop floor supervisor because they are an integral part of the production process. The amount of time to complete a job is often determined by the time standards. Customers often know when the service will be provided, cable installed, so the customer is available. The customers often link quality of services thereby. Scheduling across the organization, scheduling executes the company's strategic business plans, affects the functionality area throughout the companies. Accounting relies on scheduling information, completion of the customer's orders to develop revenue projection then and thereby. That is what we are looking forward towards it and going forward across. So marketing uses scheduling effectiveness measures to determine whether the company is using lead time for competitive advantage. Information system maintains the scheduling databases. Operation uses the schedule to maintain its priorities and to provide customer service by finishing jobs on time every time as the case with it. With this, I come to an end of this presentation. Thank you for watching this video.